Okay, is everybody looking at 9.3, number 2?
Yeah.
All right, here we go. Pippins, I think you might be on the wrong one. We're on 9.3, number 2. And if you don't do it with us, it doesn't count. I need everybody doing this with us, or I'll take points off.
Whoa.
Yeah. We're working together. Here we go. Consider the Venn diagram. Alright, so some people like logs, some people like trig. 50 kids all together, 23, 19, and 2. Alright, how many kids like only logarithms? 23. So easy. Yeah, it is. It is. How many kids like only logarithms or only trigonometry? 25? These two right here? How many people, unfortunately, like neither?
6.
How did you get 6? Because there's 50 all together, and this adds up to 44. Everybody good? Number 2, another Venn diagram. So we know the probability of apples is 0.5, the probability of bananas is 0.6, and the probability of apples and bananas is 0.3. So here are the questions. Okay, here we go. What can we fill in? We can answer these questions easily once we fill in our diagram. So in the middle is 0.3. That means this is 0.2 because A is 0.5. And this is 0.3 because B is 0.6. So what does this question say? How many people like apples, but not bananas? So in other words, only A. Well, only A is what? Only A. 0.2. Right here, right? And aren't these the only A's? And then what does this say? How many don't like either? Well, wait a minute. That would be out here, right? How many people are out there? How do we know there's 0.2 out there? Because these only add up to 0.8. Guys, with me?
Yep.
Easy. All right, number 3. Gonna build a tree diagram. Now, here's the tricky thing. When you read question number 3, did you know you were going to build a tree diagram?
Yes.
Just by the way the problem sounds? Yeah. Because you've got 2 things going on. The kid's going to take pre-cal and buy lunch, or not take pre-cal and buy lunch, or whatever, right? That's what's happening. So I'm going to build my tree diagram. And what starts?
Pre-cal and no pre-cal.
Pre-cal and unfortunately no pre-cal. I know. What? That can't be. Now, what is the probability that a kid takes pre-calculus? 0.89. So the probability he is a total loser in life is 0.11, right?
Yep.
Got it? Now, once we determine that, we're either going to buy lunch or we're not going to buy lunch. If he takes pre-cal, the probability he buys lunch is 0.34. So the probability he doesn't is 0.76. If he doesn't take pre-cal, then lunch is 0.76 and no lunch is 0.34. Those numbers just happen to be the same.
It's not 6-6.
Oh, yeah, it is 6.6, thank you. And this is 2.4, they're not the same. Thank you, you're right, thank you. Yep, that's right. Good catch, yeah, I would have just gotten the right answer. All right, now what am I trying to do? Find the probability I buy lunch. So 0.9 times 0.34. .3026 or 0.11 times 0.76. .0836. And then what do I do with those numbers? I'm gonna add them because this is an or situation. Pre-cal and lunch, no pre-cal and lunch, one or the other, and I got 0.3862. That was really easy, really easy. All right, let's look at 9.3, number 1. So everybody that's here right now in the room, do not turn in number 2. All right? You're gonna have to turn in number 1 unless you get it finished. All right? We'll start it, see how far we can get. All right, so now we've got the candy, I'm on 9.3, number 1. So I got the candies in the bags again. And I'm gonna pick one from each bag. And I want to know the probability that neither will be yellow. So the first bag, not yellow, is 0.8. The second bag, not yellow, is 0.7. And since it's not yellow and not yellow, what am I going to do with these two numbers? Multiply, and the answer is 0.56. I want no yellow and no yellow. All right, number 2, or B. What's the probability Trey gets a red and Jada gets a green? Well, Trey getting a red is 0.2, and Jada getting green is 0.2. So the answer is 0.04. And the next one is the tricky one. Notice that it says I need to get brown and green. But it doesn't tell me what order I have to get them. So could I could get brown and green, or I could get green and brown. Does that make sense to everybody? So brown and green would be 0.2 times 0.2, so 0.04 for brown out of Trey and green out of Jada. Then the other way around, green and brown, 0.06. But since it's one or the other, I'm going to add them. And the answer is 0.10 or just 0.1. 0.1. All right. That question, this kind of question right here, is the one sometimes we miss on the test if we're not careful. Everybody does brown and green, but remember it didn't say what order so it has to be green and brown. Okay? All right, number 2, we're not gonna get it down, but we can get the next one done. We only have 2 homework problems to do that. Number 2A. 5-card hand from a standard deck, denominator is 52C5. What is the probability of being dealt all hearts?
13.
How many hearts are there? 13?
C5.
C5, I went all hearts, there we go. Do not cancel, please don't cancel anything there. You gotta type it in, see what we get. .95 times 10 to the negative 4. Now, I am perfectly fine with that answer, all right? So in there, I put some weird directions in there. I'm okay with that answer. That decimal, if you wanted to change it, that decimal would be .00495. That percent would be .0495%. You don't need to worry about that. This is absolutely fine. All right? And then you're going to, well, let's do B. Let's do B. What's B? No face cards, no aces. Denominator is 52C5. What's the numerator?
40C5.
Not 40.
36.
36. Why is it 36? We took out the aces and the face cards. .145. 2 sevens. Last one, I can't believe it. 2 reds and 3 blacks. Denominator 52C5. What's the numerator? 26C2. 26C3, and these 2 guys are multiple. That's actually going to be a bigger number than we usually get. Hang on, don't leave. We're going to get this done. That way you don't have to worry about it. Wait. .325. Don't have to turn in either one of those. You're going to get the points. Unless you turn it in, and then you lose points. Well, take it home and do it again.
No.